Good morning and welcome, dear students. We are on the verge of the completion of a very interesting and important chapter, that is forces and laws of motion, in which we learn about the special quantity that is known as force and how it plays a role to create a motion in a body by accelerating that body by applying a force. Even we studied about certain laws, that is Newton's first law, second law, and third law. So today we are going to conclude the discussion on this chapter with a very essential concept of science, that is the conservation of momentum. Students, we have earlier studied in previous classes about the conservation of energy, conservation of mass. On similar lines, this law, that is a conservation of law, or I should say, the law of conservation of momentum, is based on the same concept. That means, in a system, if a bodies are in motion, their momentum remains conserved. So let us understand this with the help of the law of conservation of energy. Students, suppose the water is falling from a height on a turbine. Okay, the kinetic energy of the water is being converted into the mechanical or the rotational energy of the rotor, that means the turbine. In this way, the energy, that is the kinetic energy, is getting converted into mechanical energy of the rotor, and the mechanical energy of the rotor or the turbine is getting converted into electrical energy of the generator. So in this way, throughout the changing of the energy from one form to another, energy remains conserved. Okay, it was not created nor either destroyed. On the similar lines, let us understand the law of conservation of momentum, in which there are two bodies that is considered as m1 and m2. The body m1 is initially moving with the velocity u1, and a second body m2 is moving initially with the velocity u2. Okay, students, so they are moving towards each other in this direction. Now, when the bodies will collide, the first body will exert a force on the second body. As we know, whenever a body collides or there is momentum, the momentum produces an impact on another body, because of which there is a force acts on another body. In this way, the first body is exerting a force on the second body, which is F1, and the second body is exerting a force F2 on the first body, which is known as F2. So after the collision, the bodies will start moving with the velocity v2 and v1. The first body will start moving with the velocity v1, and the second body will start moving with the velocity v2. Now students, let us read it. When two bodies collide, they exert force on each other, as I told you, due to which there is momentum change in time t. So there will be a momentum change from initial momentum to final momentum in a certain time period, that is t. Okay, so we know that if during collision the force F1 may be m1 v1 minus u1 upon t, as we know the force is the rate of change of momentum. Similarly, the force F2 will be considered as m2 v2 minus u2 upon t. Please note, students, this 1 or this 2 in the F2 or m1 u2, that these values, that these numbers are in suffix. There was no technical quality of the software to make it on the suffix, so I wrote in front of it, that is v2 and u1. These all numbers are in suffix, please note it. Okay, now students, we know the formula of f1 is, that is m1 v1 minus u1 upon t, and f2 is equal to m2 v2 minus u2 upon t. Okay, now as we know, there is equal and opposite forces acting on both the bodies, from first body to second body and second body to first body. Okay, so the forces will be equal and opposite, so in this way f1 is equal to minus f2, and the formula for f1 will be m1 v1 minus u1 upon t. We have put it here, and the f2 will be m2 v2 minus u2 upon t. Okay, students, now if we cancel out the t, the values will come out to be as m1 v1 minus m1 u1 is equal to minus m2 v2 plus m2 u2, because the minus and minus in the bracket will get plus, so the value will be minus m2 v2 plus m2 u2. Okay, now students, if we interchange from the LHS and RHS, the values will come out to, the formula or the relation will come out to be as m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. Now what can you see, students, in this formula? In this formula, total final moment of the two bodies have been added, and in the RHS side, right hand side, there is the total initial momentum of both the bodies is being added. That means you can see that the momentum remains conserved. Okay, if there is no external force acting on the body, the total momentum of the body remains conserved. So in this way, the sum of the final momentum of the two bodies will be equal to the sum of the initial momentum of the two bodies. Okay, students. So in this way, we can understand the principle of conservation of momentum in our particular terms can be defined as follows: when two or more bodies act on each other and no external force acts on them, the total momentum of all the bodies is equal to the initial total momentum. अगर दो बॉडीज एक दूसरे पे एक्ट करती हैं या कोलाइड करती हैं और उनमें कोई एक्सटर्नल फोर्स एक्ट नहीं कर रहा होता है, तो जो टोटल मोमेंटम है दोनों बॉडीज का वो इक्वल होगा टोटल इनिशियल मोमेंटम के. ये हमारा स्टेटमेंट है जो हमें कंजर्वेशन ऑफ मोमेंटम के बारे में बताता है. Okay, so students, let's see once again. See, this is a ball or a body with mass m1. इसका mass m1 है और u1 velocity चल रही है और m2 body है, इसका mass m2 है और ये u2 velocity से दोनों एक दूसरे की तरफ चल रहे हैं. They're moving towards each other. Now when they will collide, the first body will exert a force on the second body, that is F1. पहली बॉडी दूसरी बॉडी फोर्स लगाएगी वो F1 लगाएगी और दूसरी बॉडी पहली बॉडी फोर्स लगाएगी वो F2 लगाएगी. इन दिस में हमें पता है न्यूटन के थर्ड लॉ के हिसाब से कि देयर इज इक्वल एंड अपोजिट फोर्स. Okay, so the forces are equal, that is F1 and F2 are equal, but they are equal and opposite, so their minus sign will be put here. In this way फॉर्मूला हमें F1 का पता है, रेट ऑफ चेंज ऑफ मोमेंटम होता है, दैट इज m1 v1 माइनस u1 अपॉन t, और F2 का रेट ऑफ चेंज ऑफ मोमेंटम के हिसाब से सेकंड बॉडी है तो उसका फॉर्मूला क्या हो जाएगा m2 v2 माइनस u2 अपॉन t, and the relation will come out to be as m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. Now students, based on the conservation of momentum, there is a very important concept of the recoil velocity of a gun. Suppose you must have tried or fired a gun once in your life. So when we fire a gun, the bullet moves in this direction. This is the velocity of the bullet. The bullet is moving in this direction, and equal and opposite force acts in the person who is holding the bullet or the gun. So the person who is holding the gun will experience and opposite or a reaction force on the gun because on his shoulder. So this opposite force which is acting on the body on the gun is known as the recoil velocity of rifle. So let's see, when the bullet is fired, it leaves the barrel with a certain force. जब बुलेट को हम फायर करेंगे तो वो बुलेट लीव करेगी बैरल को या गन को इस डायरेक्शन में. द आउटगोइंग बुलेट कॉजेज अ रिएक्शन ऑन द गन. जो आउटगोइंग बुलेट है ये इस तरफ डायरेक्शन बुलेट जा रही है, एक रिएक्शन फोर्स इस तरफ लगाएगी जिसे हम कहते हैं रिएक्शन फोर्स, और वो फोर्स क्या होगा, वो इक्वल एंड अपोजिट होगा जो गन पे लगा है और उसका रिकॉइल वेलोसिटी का है. देखिए, फर्स्ट ऑफ ऑल द गन को हमने फायर करा, द बुलेट इज मूविंग दिस डायरेक्शन और एक रिएक्शन फोर्स बैकवर्ड लगेगा. सो ये वेलोसिटी ऑफ बुलेट है और ये वेलोसिटी रिकॉइल वेलोसिटी ऑफ राइफल है. दैट मीन्स द गन इज रिकॉइलिंग और द राइफल इज रिकॉइलिंग. ओके, नाउ बिफोर फायरिंग बोथ द गन एंड द बुलेट आर एट रेस्ट. फायर करने से पहले दोनों रेस्ट पे हैं, बुलेट और गन. ठीक है, तो इस वजह से उनका टोटल इनिशियल मोमेंटम गन और बुलेट का बिफोर फायरिंग क्या हो जाएगा, 0 हो जाएगा. नाउ mass of bullet we are considering as small m, mass of gun we are considering as capital M, velocity of bullet as v, and velocity of recoil as capital V. Now from the principle of conservation of momentum we can understand that mv plus mv is equal to 0. That is small m mv and capital mv is equal to 0. ये बुलेट का मास है और ये गन का मास है. ठीक है, और ये इक्वल टू 0 क्यों हो जाएगा, क्योंकि हमें पता है क्योंकि इनिशियल मोमेंटम क्या हो गया है, इनिशियली द राइफल एंड द बुलेट आर रेस्ट, सो द इनिशियल मोमेंटम दोनों का क्या हो जाएगा, 0 हो जाएगा. व्हेन वी ट्रांसफर इट टू अदर साइड, द वैल्यू विल ऑफ द रिकॉइल वेलोसिटी ऑफ गन की वैल्यू हमारी जो फॉर्मूला निकल के आएगा वो है माइनस एम वी अपॉन एम. इन दिस वे नेगेटिव साइन जो आ रहा है फॉर रिकॉइल वेलोसिटी ऑफ द गन के लिए, दैट मीन्स इंडिकेट्स दैट द गन रिकॉइल्स इन अपोजिट डायरेक्शन टू शॉट, क्योंकि गन इस डायरेक्शन रिकॉइल होगी ना कि इस डायरेक्शन रिकॉइल होगी, इस वजह से वो नेगेटिव आया है. ओके स्टूडेंट्स, thank you. On based on which we are going to solve more numericals or based on the recoil velocity of gun, and even on the base on the conservation of momentum formula, that is total initial momentum is total final momentum. So students, please listen it and try to understand it, and please solve the derivation thrice once again in your copy on your own, so that you should be able to understand its derivation properly and its basic concept. So it has numerable number of applications in the field of wagons, in the trains, in the railways. So the momentum of the engine is being transferred to the momentum of the wagons. So in this way, the conservation of momentum have a number of applications. So this is a basic concept which I tried to explain you. Thank you students, thank you very much.